So we're going to add an extension to the definition of continuity. We're going to add the extension of closed intervals. So let f be defined on the closed interval. So previously our definition was for open intervals. For some real numbers, a less than b. So all we know is a is less than b, all right, in some closed interval. F is continuous on AB if f is continuous on the open interval. And then what are we doing? We're now only going to be concerned with, looks like the limit as x goes to a from the right as of f of x is equal to f of a, and the limit as x goes to b from the left is equal to f of b. So what does that look like? Okay, so adding this extension makes f continuous for all of the following intervals. All right, so now what are we doing? We're adding in this negative 10 and this 2. So what am I talking about here? Well, we got to go back to our original graph we were working on in the previous video. So in this graph, okay, when we originally talked about continuity and where it was continuous, we said it was continuous on this open interval from negative 10 to negative 7, right? And we said that it was not continuous at negative 10 because the limit did not exist. However, with the closed interval definition, all that we need is the limit on the right side to exist, and not just and not both the left and the right. When we're talking about that lower value, that's what this is saying here. An a value, that's on the left hand side, right? So if that right hand limit exists on this lower value and it equals that output, okay, then we could say for closed intervals that does fall under there. And then all of a sudden this becomes a bracket instead of the parentheses that we had. So that's where that's coming from. Okay. Now it doesn't extend here because it's still not defined there, right? And it doesn't extend at negative 4 because it's undefined. Same thing with 2. Same thing with 4. I'm sorry, not the same thing with 2. Because look, now all of a sudden at 2, why was this not? Because the left and the right hand limit did not line up. However, if I do the left-handed limit here, then what's going to happen? Well, or I'm sorry, the right-handed limit there, the limit actually does exist at 1. Okay, so x equal to 2, all of a sudden you do end up getting this bracket thing going on here. Typically, textbooks don't go into this closed interval definition, but for whatever reason, this one does. So normally this isn't really an issue. We just only consider open intervals here. But technically what's going on here, if you use the closed interval notation or the closed interval definition, then it does. Okay. So the problem becomes this. So you might be tempted to say, well, look, on the open interval from negative 4 to 2, it's continuous. And now by this definition, on the closed interval from 2 to 4, okay, it's closed on one side and it's open on the other side, is continuous. Meaning what? Meaning from here to here, we're continuous. But then from 2 to 4, we're continuous, right? Now, the problem here is if I try to combine these two, and then all of a sudden I say, oh yeah, well, if I look at a number line and I have 2 here and negative 4 here and 4 here, well, this is open here, but then it closes here, and it's like that. So therefore, we're good all the way through, right? That might be a temptation. don't fall for that temptation, okay? Clearly, you can say there's a vertical asymptote there, and the function is discontinuous right there. So it gets kind of hairy. You might have some homework questions that are assuming the closed interval method. I don't think that I'm going to use the closed interval method on any test questions. So what I've just introduced this to you in case you run into it in your textbook. And so like for a test though, we're gonna assume this original definition here where we're only dealing with these open intervals. So just make sure you make a note of that whenever you start to go studying for the test. These are more what you're going to see in other math classes, so that's kind of where I'm focusing on, just concentrating on open intervals, because it gets a little confusing whenever you start saying, oh well, it's continuous here, and then you might think that it's continuous all the way across. All right, guys.